Hello everyone, my name is Cody and I'm a science explainer here at the Discovery Centre. You might have seen me over the school holidays doing a science show, or maybe you've just seen me on a normal weekend. Now unfortunately, due to the COVID restrictions, we have had to close our doors, but luckily we'll be running a different session every day of the week for the foreseeable future. So I will be here with a new video at 2 o'clock every Thursday called Exploring Experiments with Cody. And to start off today, I have two demonstrations I'm going to go through with you all. So let's get started. What we're going to be making today is our very own lava lamp. Now this is one I made earlier today, but the next one we're going to be making is going to be red. But the colour doesn't really matter, it just depends on what kind of food dye you use. So to make our very own lava lamp, we're going to need a bottle. I've got quite a big one. I would probably recommend using a 600ml one. We need some water. We need some vegetable oil. Make sure you ask Mum before you use all that vegetable oil. We're going to need an Alka-seltzer tablet. And finally, some food dye. As I said before, I have some red food dye today. So what we're going to do today, we're going to open our lid and we're going to fill our bottle 1/3 of the way up with water. So I had already measured out what 1/3 of this bottle was, or how big I wanted my lava lamp to be. So here we have a water, that's 1/3 of what I want it to be today. And then we're going to put a few drops of our food dye in. Put a couple drops of our red food dye in with the water. A couple of drops have gone down the side, that's right. You'll need to give it a bit of a shake anyway, so that they can mix together. Once we've got our food dye in, like I said, give it a bit of a shake. Make sure the lid's on properly, you don't want this going everywhere. And there we go, we have some red water. And what we're going to do now is we're going to put our oil in. Now once again, this is 2/3 of the size of the bottle I want. I've already measured it out. Going to pour that in over the top of our mixture. Carefully doing it, don't want to spill this everywhere. Slowly but surely. And I have put it all in. So once again, you want to give it a bit of a shake. And our lava lamp is nearly finished. I wanted to make quite a small one today because I have such a big bottle. But you can see the two liquids don't quite mix together. Now, in a real lava lamp, they would use light to make it all bubbly and look weird. Today, we're going to use our Alka-seltzer tablet. So we're going to take that out of the packet. We're going to snap it in half because it's a little bit too big to go on the bottle. And we're going to drop that in one at a time. And then close the lid again. Give it a bit of a shake again. And you leave that sitting, and that tablet is going to make some bubbles. If you watch it carefully. And that is how you make your very own lava lamp. Now the reason it looks like this is that water and oil are unable to create a chemical bond, so they don't mix together. This is why they remain completely separate. You can take a closer look there. You can see the bubbles forming. I'm going to give it a bit of a shake when that happens. Now, if you leave this alone for a while, the water and the oil will separate. The oil will all float to the top. Much like if there was an oil spill in the ocean, that usually all floats to the top as well. Now, the reason it does this is that the food dye is what we call a hydrophilic compound, which means it loves water. So it mixes together with the water and loves to combine, which is why we got our red water at the start. Now, oil is what we call a hydrophobic compound, which basically means it's scared of water. So it refuses to properly mix with our water, which is why they stay separate and create our lava lamp. Now, the Alka-seltzer tablet was dropped in. Like I said before, with real lava lamps, they would usually use light, but we dropped that in to create some carbon dioxide bubbles so that our lava lamp fizzes up. But really, that's all it takes to create your very own lava lamp. You want to be very careful with this one. I would ask permission from Mum or Dad before making that. But there you go. So I'm going to put these to the side here. Now, I actually have one more demonstration for you all today. I don't know if you were able to make it, but over the school holidays that most recently came up, our theme was flight, and we spoke about the flight of a dragon. Now, one of the main things we focused on was called Bernoulli's principle. If you did go, you might remember that was the one where we used a blow dryer to make some paper float, and then we put a reel of paper on a leaf blower and blew it all over into the crowd. Now, I'm going to demonstrate that in another way today. This is another very simple one. Have a hair blower and a ping pong ball. Now, if I turn my hairdryer on and put my ping pong ball on top, it will float up just like that. Now, because of Bernoulli's principle, if you actually start tilting, our ping pong ball was able to stay in our air current. Now, this is because of, like I said, Bernoulli's principle. What it does is it creates a low pressure zone at the top and a high pressure zone underneath, which helps to create a vacuum in our air current, which keeps our ping pong ball in the air current even though it's tilted. So I'm going to do that one more time. I'll put it on, turn it on, and then as you start to tilt it, you can see it's created a high pressure zone, low pressure zone, and it is staying in our air current. You can get to about a 45-degree angle before it starts to fall off. Well, we've actually now come to the end of the first week of exploring experiments with Cody. Hopefully you've been able to successfully make your own lava lamps. I don't know what we'll be doing next week, but I will let you all know. Now, thank you very much for tuning in. I hope you've all enjoyed it and hopefully learnt something new. I will actually be in the comment section for the next half an hour. If you have any questions or would like to have a chat about any of these demonstrations, I look forward to responding to you, and I hope you all tune in next week. Bye!